All right, welcome to day 12. You got your homework listed there. And we're going to be on the 3-12 in the notes packet. There's a bunch of axes drawn there. And today's topic, we're going to look at inverse trig functions. So we're going to start out with sine. So sine, we got pi over 2, pi, 3 pi over 2, and 2 pi. And similar idea over here. That goes all the way to negative 2 pi. And we got negative 1 down here and 1. Sine starts at 0. And we will continue that pattern backwards. So the domain and range, really we could have kept going forever left and forever right. So the domain is all real numbers. The range, we are from negative 1 to 1 inclusive. So you could have also written that as negative 1 less than or equal to y, less than or equal to 1. Well, now we're going to graph inverse sine. Also can be called arc sine, mean the same thing. So we need to look at a principal branch of the sine graph where the inverse exists. Well, for the inverse to exist, it must pass the horizontal line test. So we need a section of graph that passes the horizontal line test. And they try to get that principal branch to somehow be attached to x equals 0. And then if you have options for it to be positive. So for us, our section of sine that we're going to turn into the inverse is this right here. Okay, it has both positive and negative versions. And notice it's attached to when x is equal to 0. So all we're going to do is we're going to flip each of those points doing our inverse. So in the original, the x's are going from negative pi over 2 to positive pi over 2. So here, that's what our y's will go to, from negative pi over 2 to positive pi over 2. In our principal branch there, our y's go from negative 1 to 1, so now our x's will go from negative 1 to 1. And our points, we have negative pi over 2 comma negative 1. Well, now we have negative 1 comma negative pi over 2. 0, 0 is still 0, 0, and pi over 2, 1 becomes 1 comma pi over 2. And to have kind of the same shape, it'll look something like that. Our domain is from negative 1 to 1. And the range, it's not just the domain of the original because we had to cut it off so that it's a function. So our range goes from negative pi over 2 to pi over 2. So we're going to do a similar idea with cos down below. So we'll label our axes. Going from negative 1 to 1. Cosine starts at 0, 1, and then cycles through. Our domain, really, it would keep going forever left and right, so we have all real numbers, and the range, again, is from -1 to 1. So we need a principal branch, so we want it to be somehow attached to x equals 0, and we want to have both negative and positive options. So we would either want to go from 0 to pi or -pi to 0. Well, if you have the two options, they take the positive x values. So this window here is where our principal branch would be. Again, it gives us both positive and negative y values. It passes the horizontal line test so that the inverse will exist. So notice our y's go from -1 to 1. So over here, our x's will go from -1 to 1 because we flipped the x's and y's. In our principal branch, our x's go from 0 to pi. So now our y's will go from 0 to pi. Our first point was 0, 1, so now we have 1, 0. Then we have pi over 2, 0, so that's 0, pi over 2. And then we have pi -1, so that's now -1 pi. And if we sketch it in, it looks something like that. And the way to visualize how like the curvature of it should be, remember it's got to curve backwards back in, but coming back to like the right up at the top, and it's got to curve back to the left. So that's where those mounds are. The mounds are like horizontal instead of vertical. So our domain here is -1 to 1, and our range is going from 0 to pi. All right, if we go to the next page, we're going to do it for tan and cotan. So keep in mind that tan is really sine over cos. So tan has asymptotes everywhere that cos is negative. So this is pi over 2, this is pi, this is 3 pi over 2, and that's 2 pi. Then we'll have minus pi over 2, that's minus pi. This is minus 3 pi over 2, and I don't have the room to put minus 2 pi in, but it would be somewhere over there. So it's 0. Sine is 0, and cos is 1. So 0 over 1 gives you 0. And then I like to think of the tan graph just as your ASTC, where this is our A, because it's from 0 to pi over 2. This is our S, because it's pi over 2 to pi. That's our T, and that's our C. Well, in the A section, we should be positive. So that's why we know the tan graph should go up. Over here to the left, that's like being in quadrant 4. That's the C section, so tan is negative. And then once you have that, it just follows the pattern from there. So our domain is all real numbers, but x cannot equal n pi over 2, where n is an odd integer. And our range, we go forever down and forever up, so we have all real numbers. Well, our principal branch, we need a section that passes the horizontal line test that has both positive and negative y values. And we want to be close to x equals 0 if possible. So we just take in between these two asymptotes. So there's asymptotes at x equals -pi over 2 and x equals pi over 2. So we have those as horizontal asymptotes now. 0, 0 would be 0, 0. And then as x's are positive, y's get positive. When you flip that, as x's get positive, y's still get positive. And likewise for the negative, so we just look something like that. This inverse tan graph actually will come into play in like unit 6 or so. It'll become kind of important for some problems that we do. Our domain here, we've got all real numbers. And for our range, we are not including the negative pi over 2 and the pi over 2. So we have rounded instead of squared. All right, cotangent x. Cotangent is cos over sine. So our asymptotes are wherever sine is 0. So this is pi over 2. This would be pi. We'd have 3 pi over 2 and so on. Here's negative pi over 2, negative pi, negative 3 pi over 2, and so on. And pi over 2, cos is 0, sine is 1. 0 over 1 gives us 0. And use your ASTC again. That section's A, that section's S, that section's T, that section's C. Well, in the A section, all are positive, so that should go up. In the S section, tan is negative, so cotangent's negative. And then you can just follow that pattern from there. Our domain, we again have all real numbers, but x cannot equal n pi, because we had 0 pi, 1 pi, 2 pi, negative 1 pi, negative 3 pi, sorry, negative 2 pi. So where n is an integer. And our range we have is all real numbers. So we need a principal branch. We need to pass the horizontal line test. We need positive and negative y values, and we want to be close to x equals 0. So that is our principal branch that we use. So we have horizontal asymptotes at y equals 0 and y equals pi. We had pi over 2, 0, so now we have 0 comma pi over 2. And when in the original, when x's were tiny, y's were large negative. I should say when x's are, when x's are tiny, y's are large positive. So now when you switch it, when x's are large positive, y's will be tiny positives. So we're going to be down here to start. And then it swings through because on the other end, when the x's get close to pi, the y's are big negatives. So when you reverse it, when the x's are big negatives, the y's get close to pi. Our domain we have is all real numbers, and we have roundeds going from 0 to pi, not inclusive for the range. Now that can be confusing deciding where each one is. So this is a diagram that in pre-calc regents they have in their textbook that I think is really helpful. So you can just add this in wherever you have room on your page. So the red section are your 2 quadrant options for sine inverse x, tan inverse x, and cosecant inverse x. And the green are your two quadrant options for cos inverse x, cotangent inverse x, and secant inverse x. And I think this is the best picture to help remember which quadrants you could be in. So I organized it in my head. Okay, sine and cosecant make sense they're together because cosecant's the reciprocal. And then I just group it with, okay, tan's got sine on top, so it goes with the sine stuff. And then likewise with the cos, secant's 1 over cos, so that makes sense why it goes with cosine. Okay, cotangent's got cos on top, so it goes with the cos stuff. That's how I organize it in my head, which goes with which. So if we go over to the next page, we want to find arc cos of negative radical 2 over 2. Well, let's draw a little xy axis, and our first decision is which quadrant. Well, your inverse cos can be either first or second quadrant. One of those is the positive quadrant for cos, one is the negative. Well, we've got a negative, so we would want to be over in the second quadrant. You always want to think about if that square root of 2 over 2 has been rationalized, which it has been. Originally, it's 1 over square root of 2. So really, we want to put negative 1 and square root of 2 in for our adjacent and our hypotenuse. And again, that's coming from that cosine is a over h, but we want the non-rationalized version because that will match with our special right triangles. The other side is just 1. And we just want to know what this angle is here. It's a 45-degree reference angle, meaning from here we went 135. And then we would need that in radians, so it is 3 pi over 4. We're going to jump to number 3 now. Arctan is negative. Well, if you look at your chart, the negative tans would have to go between those two options in the fourth quadrant. So we'll draw our reference triangle here. The unrationalized version of this is negative 1 over radical 3. So the opposite is negative 1, the adjacent is radical 3, meaning that's 2, and meaning this is a 30-degree reference angle. Your values you get back when you do an inverse or an arc is always how did you move directly to where you are from 0. And by directly, you're not doing like 3/4 of a circle. So we're going directly there. We went backwards 30, so that's negative pi over 6. In regular sine, cosine, tangent, you sub in an angle, you get back a ratio. So in inverse, you sub in the ratio and get back an angle. We're going to do 5 together next. So arc cos of 0. So what that's saying is when you have a ratio of 0 for what angle value of cos? Well, cos is 0 at pi over 2. That's one of our nice values from the unit circle. So what I'd like you to do is I'd like you to pause the video right here, try each of these 3 other ones, and then restart the video. There'll be at least one question that pops up to ask you to put in your answer, and then we'll go through the other ones. So again, pause it here, do these 3, and once you've done 2, 4, and 6, restart the video. All right, sine is positive, so first quadrant, opposite. Hypotenuse, this is 1. This is a 60-degree reference angle. So here, directly to there, would be pi over 3. Cotangent's negative quadrant would be the second quadrant. This is really negative 1 over 1 for our adjacent and opposite, making this square root of 2. Reference angle is 45. So this is just like number 1. We end up with 3 pi over 4. A negative sign, we should have been in the fourth quadrant. This is opposite and hypotenuse, making this square root of 3, making this be 30. And just like the one right above it, we went backwards, pi over 6, so you have negative pi over 6. All right, going down to the bottom. Cosecant of arc cos negative radical 2 over 2. So we're going to start out with the inside, and that's going to tell us where to set up our triangle. A negative cos is second quadrant. This really, before it's rationalized, was -1 over square root of 2. So we've got our adjacent, and we've got our hypotenuse. Either using a special right triangle or Pythagorean theorem, we can get that other side. All right, we've done the middle now. Now that you have your triangle set up, now you just do cosecant. Well, cosecant is the reciprocal of sine, so that's hypotenuse over opposite. If you do your hypotenuse over your opposite, that's square root of 2 over 1, which is just square root of 2. We'll do one more together, then let you try the other three. Sine is positive, so we're in the first quadrant. You've got your opposite, you've got your hypotenuse. Again, you could either do Pythagorean theorem or special right triangles in this case. When you get down to some of the other ones like 4 and 5, you'll only be able to do Pythagorean theorem. So we've done the inside now. We've done the inverse sine. Now it's just asking us to do cos for that triangle, so we just get 1/2. So go ahead and pause the video, try the other three. You'll have a question pop up when you unpause it. It'll ask you your answers of at least one of them, and then we'll go over each of those. So again, pause it right now until you've finished the next three. Tan's positive quadrant is here. Opposite over adjacent is 1 and 1. You get square root of 2. So sine of that would be 1 over square root of 2, or in other words, square root of 2 over 2. Sine's negative quadrant is the fourth quadrant. Opposite is -5. Hypotenuse is 3. Pythagorean theorem, or knowing your Pythagorean triples, would tell us this is 12. So now from this reference angle, do cotangent. That is adjacent over opposite, so we have -12/5. And the negative cotangent quadrant is the second quadrant. Your adjacent is -3, your opposite is 4. Pythagorean theorem, or knowing your Pythagorean triples, gets us that 5. And now we want to do cos for that reference triangle, so we'd get -3/5. All right, well, next one, we have a problem just like we did, but we have x instead of a value. Well, the problem is we determined where to set up our triangle by if x was positive or negative. Well, let's look at if x is positive, we would be in the first quadrant. And then down below, we'll do if x was negative, that'll be in the fourth quadrant. And we'll look at both cases and see how they compare. So this is really x over 1. So opposite is x, and our hypotenuse is 1. So we're going to do Pythagorean theorem now. We'll say x squared plus b squared equals 1 squared. That's x squared plus b squared equals 1. B squared will equal 1 minus x squared. And b is going to equal plus or minus square root of 1 minus x squared. Well, the side we're looking for goes right, so we must have the positive version of that. So square root of 1 minus x squared. They want us to do tangent. Tangent is opposite over adjacent. So we're going to have x over square root of 1 minus x squared. Then we got to rationalize. So that's going to become x squared of 1 minus x squared over 1 minus x squared. All right, now we're going to assume that x was negative. So we'll have x for the opposite. We'll have 1 for the hypotenuse. Now you may say, why are we not calling that negative x? Well, if we're assuming x is a negative number, calling it negative x would make it positive then. It would negate the negative. So we're assuming x is negative, so we just call it x. If you go through and do Pythagorean theorem, we're going to get this again, because they were all in the same spots. If we now do tan, we will again get x over radical 1 minus x squared, and eventually it will rationalize to this. So notice, x will just end up working out to be whatever it is. If x was positive or x was negative, it doesn't matter. So you can really just work with the triangle. It doesn't necessarily matter the quadrant. Okay, but that's only if it's the variable x and if it's not some number. All right, that's it for this video. Have a great rest of your day.